Hello, we are Group 13 and today we're going to introduce you to some of the downsides of component diagrams. Unless this video is the first one you watch for this week, you have already seen and heard what component diagrams are all about, but if I repeat it just one more time, then hopefully we'll understand and remember it even better. First of all, where do they stand in the UML diagram hierarchy? As you can see on the slide, they are categorized under structure diagrams right next to the already familiar object and class diagrams. Component diagrams can be seen as one step up on the abstraction ladder in comparison to the class diagrams, as each component can be implemented by one or more classes. Here you can see an example of a component diagram, to which I've added some colorful arrows to point out the parts I'm talking about. A component is like a subsystem which communicates with other parts of the bigger system. On the diagram, they're represented as rectangles that are marked either with the keyword component or the component icon at the top right corner. For example, we have component product shown by the red arrow. In an earlier version of UML, this icon shape was used instead of the rectangles to note components, but for the newer version, the simpler rectangles were chosen. All components can provide and need different interfaces. Such a relationship is represented with a connector. For example, the order component needs an item code which the product component can provide. In this connection, indicated by the green arrow, the required interface is shown by a half circle at the end of the line, while the provided interface is represented by a full circle. The relationships we're already familiar with also apply here. For example, the blue arrow points to an association between the customer and his account. We can also see a dependency relationship indicated with the purple arrow that connects the provided account details to the required payment. And finally, we have ports, which are used to specify the interaction points between the component and the surrounding environment. For example, we can see 3 ports on the order component, one of which is indicated by the yellowish arrow. One port is used for receiving the item code, another one for receiving customer details, and the third one for receiving account details. Now, I know we're supposed to be focusing on the negative aspects, but before attacking the poor component diagrams with all the strong arguments about why they're bad and should never ever be used, I figured it'd be good to soften the blow and very briefly bring out a few positive aspects as well. Component diagrams describe the autonomous parts of the system. Therefore, they give us a clear overview of what value each component brings and what inputs it needs to operate properly. Seeing this, we might also be able to eliminate unnecessary components from the system. So the key phrase would probably be shifting our attention from describing the functionalities to describing the parts that are responsible for those functionalities. But now, if you want to hear more justifications about using component diagrams, I recommend that you switch to a different video because from now on, we will only be focusing on the downsides.
One problem component diagrams have is that for some tasks they're not really abstract enough, and for others they're too abstract. Like they're too detailed or technical for use in like big meetings or with people who are not that technical, or in general it's not good for showing a big overview of how the system works or how some part of the system works, because there's a lot of detail there that you really don't need for that. Like which component goes in which file and all that is kind of irrelevant there. It's only gonna make the diagram noisy and difficult to read. So you're much better off using some other diagrams for that purpose. And on the other side, you can't really use component diagrams on their own for implementing stuff because there's really not enough information there. In implementation, you're always going to need object or class diagrams with it, and so it's going kind of only as a companion for those diagrams that component diagrams are really useful. So that's why the scope is so small, is because they don't really go far enough in either direction. Another reason why you might not want to use component diagrams is that in simpler systems especially, a class diagram might be enough for what you need. All the purposes a component diagram would serve are already taken care of by the class diagram, which is because components are often made out of classes, so the two diagrams often look fairly similar. Obviously, some abstraction is made in component diagrams, but I think with a little extra thought, you can see all that information from a class diagram anyway. And not having a component diagram obviously saves you a lot of time. There's a bunch of extra notation and rules that you need to know anyway, so as the class diagrams are more often used than in component diagrams, you might run into the problem of some people might be a little unfamiliar with them, and so just using one class, one diagram might be simpler. And as you can see in this example, which is maybe a little too trivial, but I think it kind of works anyway, is that the class diagram and component diagrams are very similar. Only real decision that's been made in the component diagram is to put the subclasses of the class order into the same file as order. And I think you can make that sort of decision based on the class diagram as well. You don't really need that extra diagram. And so a class diagram might be all you need.
I will talk about 3 somewhat related problems with component diagrams. Firstly, synonymity. The same idea can be conveyed in multiple ways. For example, a component can be shown in at least the 4 following ways. A rectangular container with the component keyword and the name of the component in bold, a rectangle with an icon in the container, a rectangle with both the keyword and the icon, or with the icon as the container. The similar is true with interfaces. You can use the word use with a dashed line and an open arrow to indicate that one module uses another. You can also explicitly show the interface that is used and which functions it consists of. Or you can just use the so-called lollipop icons, optionally also showing the function name that is required. This freedom to choose is not necessarily bad, but it is important to be consistent within and across diagrams to avoid information noise. Another problem relates to the fact that component diagrams should not capture everything about the system's implementation view. Every component represents just one aspect. However, this can lead to many component diagrams, each conveying only a small amount of information. Therefore, it is important to carefully choose which aspects of software we wish to have component diagrams for. We should ask questions like, what is the purpose of this diagram, what is gained out of it, and for whom it is for. And these are questions that should be asked of every diagram type. Thirdly, component diagrams are hard to do well. What details to show and what to hide. It is easy to show too many irrelevant details. So instead of showing ports and their names, along with further dependencies of a component, we can consider omitting those entirely if each component only has a single port, or the names of the ports don't matter. If the purpose or details of an interface come out in other diagrams or are evident, we can also omit the names of functions.
Dependencies in UML component diagrams typically point from a component to an interface. Most UML tools allow for relations like dependencies to exist only if they are connected to an entity at both ends. This is appropriate since relations are not considered first-class entities in UML. However, this makes it impossible to show unmet requirements. Well, this is unproblematic for class diagrams because classes are usually designed at the same time as their associations. This is an inadequacy with respect to architectural diagrams. The designer of a component-oriented application will build it iteratively by taking a small set of components and then adding more components, possibly rearranging the architecture at the same time. A designer needs to be aware what is missing in the application that is being built. he or she needs to know what components are needed in order to make existing components work. In conclusion, component diagrams have quite a lot of disadvantages, such as being not abstract enough for one task and too abstract for another. Also, if the system is simple enough, class diagrams should be a better option. They're also too synonymous and hard to do well. In addition, it is impossible to show the unmet requirements in a component diagram. Thank you for listening and goodbye.